Hey everyone, so I'm going to do my best to clear up any confusion you may have between geometric and arithmetic sequences. So the first thing I'm going to state are the formulas. Now there are two different formulas, the explicit and the recursive, and the difference between an explicit is that it can find any nth term you want. So you can find any nth term you want. That means that you can find the 7th term, the 6th term, and so on and so forth. Recursive means that you need the n-1 term or the n+1 term, however you see it. But basically that says that you need the one before it in order to get the next one. Okay, now your reference sheet gives you your explicit, and for geometric it would be a sub n equals a sub 1 r to the n-1. That's given to you on the reference sheet. The recursive formula is not, unfortunately, and there are two kinds. The first one is a sub n equals r a of n-1, which basically says that if you multiply any term by the previous term, or if you multiply the ratio by the previous term, you'll end up getting the next term. Okay, and the other one that some people use is a of n+1 equals r times an. Okay, so those are your two recursive formulas for geometric. For arithmetic, the explicit formula that is given to you on the reference sheet is a sub n equals a1 plus n-1 times d, which means that you can find any form or any term in that sequence as long as you have a1 and d. Recursive, there are also two of them. They look very similar to the geometric ones, and it's the same exact thing, just with a d instead of an r, so it's going to be a sub n d plus, because you're arithmetic, a sub n-1. Had a little trouble writing, but that's okay. A sub n-1. Okay, and the other one would be a sub n+1 equals d plus a sub n. Okay, so I prefer the first of the two, but they both work. Okay. Now, what's the difference? Arithmetic means that you're adding the same difference. So think about ladybugs. In this case, in like a real life situation, you're always going to be starting out with a0. So like no time has passed. You're starting out with one ladybug in this case. So a sub 0 in this case is 1. Okay? Now, this is when things get different, because in arithmetic, you're adding a difference. It's a common difference. And in a geometric sequence, you are multiplying. You're doing a ratio. I want to make them the same for this case so you guys can see the difference. So for arithmetic, if you are adding 2 to the previous term, that means that a1 would be 1 plus 2, which gets me 3 ladybugs. Okay? Then a2 means I'm going to take those 3 ladybugs that I have and add 2 to those. Okay? And that gets me 5 ladybugs. So this represents a0, and this represents a1, and this represents a2. So then I want to find a3. And that means I'm going to take the 5 ladybugs that I have and add 2 to them again. That means I have 1, 2, 3, 4, 5, 6, 7 ladybugs. Okay, so basically, you realize you are just 2 more than you were previously. Okay, for geometric, it acts like an exponential function. And in this case, because your ratio is 2, that means you're doubling everything. So for a sub 1, you're just going to do 1 times 2, because 1 is the previous thing, and that gets you 2 ladybugs. Okay, then for a sub 2, well, you need the 2 ladybugs that you had already times 2, and that means that you have 4 ladybugs. Okay, and then for a sub 3, that means those 4 ladybugs that you have are going to get multiplied by the ratio again. That's going to be 1, 2, 3, 4, 5, 6, 7, 8 ladybugs. Now, what happens here is that this is where things get really different, because if you remember, exponential functions grow very fast. So at A4, you're going to have 8 times 2, which gets you 16 ladybugs. Okay, that's for A4. And then A4 for the arithmetic means that you have 1, 2, 3, 4, 5, 6, 7 to start, add 2, that's just 9. 2, 3, 4, 5, 6, 7, 8, 9. Clearly you can see the difference here. This does not grow as fast as this. But the main idea is that in a geometric, you are multiplying by something, in this case it was 2, and in arithmetic you are adding by that same thing, previous to the previous thing you have. That's the whole idea of recursive. You need the thing before it to find the next thing. Okay, so let's do some more examples. Now, here is another example. So a geometric would be multiplying. So in this case, we're multiplying by 2 to get this, then multiply that by 2 to get this, and this is exactly the example of the ladybug. And if you kept going, you would get this. Now, in just a regular series, they usually give you A1 to start with, and this is A2, and this is A3, and this is A4, and this is A5. So they say, okay, what's the 5th term in your sequence? That's your 5th term. Okay, same idea for arithmetic. In the bottom here, if you realize, you say to yourself, okay, how are we increasing? By 3. Every time we are adding 3. Okay, and this would be A1, this would be A2, this would be A3, and this would be A4, and this would be A5. So this represents the 4th term, where n is equal to 4. That's like that nth term thing. Nth term means what placement you are. Okay. Now, let's convert from recursive to explicit. First off, I know these are explicit formulas because in both of these, I see that there's an n minus 1 here. Okay? And basically, if you go back to the previous slide, or if you go back to the beginning of the video, this right here and what's between there is going to tell you whether you're geometric or arithmetic. For the first one, I'm clearly geometric because I have a multiplication symbol here. That means r is equal to 5 in this case. Okay? And they give you a sub 0, which is nice because you want the explicit. And on the reference sheet, the explicit formula for the geometric sequence is this. A sub n equals a1 r to the n minus 1. Now you know that the ratio is 5. We just discovered that. But all you have is a sub 0, and you need a 1 to plug into the formula. So, well, you know the ratio. To get the next term, you're going to take 2 and multiply that by 5. That gets you 10. So this is your explicit formula. I'm going to put parentheses around that. Okay. So same exact idea for the other one, except it's arithmetic. And again, I know it's arithmetic because of the plus sign, and that means that here is my difference, because that's saying basically every term that I plug in, I'm going to add 5. Okay, and so when I plug this in to my explicit formula, my explicit formula on the reference sheet is an equals a1 plus n minus 1 times d. I need d and I need a1. Clearly you can see that the d and the r are the same in these examples, but what is different is definitely the a1, because you have a0 as 2, which is the same, but because it's arithmetic, to get a1, if this is a0, you're going to add 5 to him, and that gets you a1, which is 7, and that goes in here. And this whole thing here actually is the recursive idea, because you need the previous term, which was a sub n, adding 5 to get the next term, which was a1. Alright, so one last example, and then we'll be done with this video. It says, if a geometric sequence has a2 as 495, and has a6 as 311, they want you, I'm going to do a different color, they want you to find r, the ratio, okay, to 4 decimal places. First off, I see geometric, so I say to myself, okay, well, my reference sheet gives me this, so I'm going to use this as a formula, a1 r to the n minus 1. Now, you don't know r, nor do you know a1, but they do tell you this right here. So you're going to set up a system of equations, and you're going to utilize this guy right here. So you know a2, and if you plug into here, r to the 2 minus 1, because that's what n is, and you know a6, r to the 6 minus 1. Now you also know a few other things. Okay, you know a2. This whole formula can change into not a2, but 495. So I'm going to replace this a2 with 495 equals a1 r 2 minus 1 is 1. Okay? Okay. And then for a6, I am going to use the 311. And I'm going to basically replace this guy here with 311. 311 equals a1 r to the 5th, because that's what 6 minus 1 is. Now, what I'm going to do is I'm going to utilize my multiplication of equality rule. And that means that I can just divide these two things out. The a1s will cancel. 495 divided by 311 is approximately 1.59. R to the first and r to the fifth have the same base, so it's going to be r to the 1 minus 5. And that is going to get you 1.59 r to the negative 4. To get the r alone, you're going to take the the reciprocal of it, and you're going to raise it to both sides. These cancel out and become 1, so r equals, make sure you guys are raising it to the negative 1/4 power, and they want you to approximate it to 4 decimal places, so 0.8903. Okay, that's your rate. And the nice thing is that you could always find a1 with the rate. You can actually find any term you want with a1, well, with the rate, and it gets you a1. But for this problem, all they want you guys to do is to find the common ratio, and that was all the work to do that. I hope this helped. I'll see you tomorrow.